All right, so the last few questions are going to be related to density, and there's going to be two different types of density that we're going to be talking about. The first is going to be an object's density. This is how, essentially how heavy an object is, or like how much mass there is in a specific unit of volume. So an object's density is going to be equal to mass divided by volume. And mass is like the weight. So that's like the weight of the object. And then population density is how many objects there are in a specific area or volume amount. So population density is going to be objects. Sometimes it's people. Sometimes it's, in this first problem, is organisms. Sometimes it's trees. It just kind of depends on the problem. So it's going to be objects that are in a specific area or a specific volume. So it's objects divided by area or volume. So we have an object density, or we have population density. So in number 1, it says a biologist is studying small organisms in a rectangular tank of water. She estimates that there are approximately 54 organisms in each cubic foot of water. The tank is 7.3 feet long and 4.2 feet wide, with a depth of 3 feet. Based on the biologist's estimate, how many organisms are in the tank? So we are given a population density that there's 54 organisms in each cubic foot of water. So that is the population density in that particular tank. And then we're trying to figure out how many organisms there are. And we know the length, width, and depth or height of the tank, so we can figure out the volume. So the very first thing we're going to do is we're going to figure out the volume of the tank. So we're going to multiply those three values together. So we have 7.3 times 4.2 times 3. So 7.3 times 4.2 times 3. So volume equals length times width times height, which is 7.3 times 4.2 times 3. So their overall volume is going to be 91.98, and that would be cubic feet. So that's feet cubed. So that's going to be the volume. And then we know the density. So the population density is going to be equal to the amount of objects, or in this case, those microorganisms, over the volume. So let's go ahead and fill in everything we know. We know the population density is 54 organisms per cubic foot of water. We don't know how many organisms we have, but we know the volume is 91.98. So if we know that there's 54 organisms in each cubic foot of water, and there's 91.98 cubic feet in that particular tank, then we can multiply those values together. So 54 times 91.98, and we're going to get X being equal to 4,966.92, or approximately 4,967 organisms. All right, so in the next one, we have a farmer is studying the amount of solid particles in a small pond. He determines that the average density of the particles in the water is 100 milligrams per liter. The pond contains 200,000 liters of water. What is the total mass in kilograms of the particles in the pond? So it does say our density is going to be in milligrams, but we want our total mass in the end in kilograms. So we are going to have to do some converting after we get done. So let's go ahead and set this up and figure out the mass. and then we'll convert that after. So our density is 100 milligrams per liter. We don't know the mass, but we do know the volume is 200,000 liters. So you're going to multiply by 200,000 with the 100. So our mass is going to be 200,000,000. So it's going to be 20 million milligrams. Now, we have to take that amount and we have to convert it to kilograms. So, in 1 kilogram, there are 1,000,000 milligrams. So, to go from milligrams to kilograms, we're going to divide by 1,000,000. So, 20 million milligrams is 20 kilograms. So 20 kilograms would be our answer there. All right, in our next problem, it says the table below shows the population and land area in square miles of the United States in 1800 and in 1810. The increase in land area was mainly due to the Louisiana Purchase in 1803. Based on the data in the table, which of the following statements are true? Select all true statements. So if you look at all of the statements, they're all related to population density. So we do need to figure out the population density in both years, and then we'll be able to compare them. So to find the population density, we're going to divide the population by the area. So we're going to do population divided by area to figure out the population density. So I'm going to go ahead and do that for the very first year, which would be 1800. So I'm going to take the population, which is 5,308,483, and I'm going to divide that by the area in square miles, which would be 864,746. And then I end up with a population density of 6.1 people per square mile. And then I'm going to do 1810, which we would have 7,239,881 divided by 1,681,828. So we end up with 4.3 people per square mile. So we're going to do go through the answer choices and pick which ones are true. So the population density increased between 800 and 1810. That is not true. It actually decreased. The population density in 1810 was approximately 6.1 people per square mile. That's going to be wrong as well. The population density changed by approximately 29.9% between 1800 and 1810. So I'm going to have to figure out the percent change. So I'll do that in just a second for C and D, so I can figure that out. And then the population density changed by approximately 1.8 people per square mile between 1800 and 1810. So I need to figure out the difference as well. So let's figure out the percent change first. Okay, so let's figure out how many it changed. So let's do 6.1 minus 4.3, which was 1.8. So it did change by 1.8 people. It went down 1.8 people per square mile. So E is true. And then let's figure out what percent change that would be. So we're going to do 1.8 divided by 6.1. So you divide it by your original. And we end up with 29.5%. So I'm going to pick the one that's closest to it. So I'm going to say approximately 29.9%. So C. D would be, I think, the answer if we divide it by 4.3. Would that be right? Yep. So, well, I mean, that ends up being 41.9, so that is kind of close to D. But when you're doing percent change, you do the change divided by the original amount before it changed. So we got C and E are both correct there. All right. And then our last two questions are related to an object's density. So it says lead has a density of 11.3 grams per cubic centimeter. The sides of the base of a solid right square pyramid made of lead measure 3 centimeters. The height of the pyramid is 6 centimeters. What is the mass of the pyramid? So density is going to be equal to mass over volume. So we do need to figure out the volume of this pyramid. So volume is going to be equal to 1/3 the base area times the height, which would be 1/3. The base area is going to be 3 squared, 3 times 3, which is 9. And the height is 6. So 1/3 times 6, 9 times 6. So that's going to be end up being 18. So 1/3 times 9 is 3, and 3 times 6 is 18. So our volume is going to be 18 cubic centimeters. We have the density, so the density is 11.3. We don't know the mass, that's what we're trying to find. And then the volume is going to be 18 cubic centimeters. So if I do 11.3 times 18, I should get the mass. Which ends up being 203.4, and that would be 203.4 grams. And then Leon has a solid right square pyramid. So again, we're doing another pyramid. The height, gives the perimeter of the base is 10.8 inches. So if it's a square pyramid, that means the base is a square. So if it's 10.8 is the perimeter, then each side is going to be 2.7 inches. So I just divided that by 4 to get that amount because there's 4 sides in a square. And then it gives us the density is 0.26 kilograms per inches cubed. So I need to figure out the mass of the pyramid. So I'm going to have density is equal to mass over volume. So the same formula there. So I'm going to have 0.26 is equal to mass over volume. So I do need to find the volume. It's still a pyramid, so it's going to be the same formula that we started with here. So 1/3, the base area will be 2.7 times 2.7, which is 2.7 times 2.7. It's going to be 7.29 times our height, which is 3.1. So 7.29 times 3.1 times 1/3 is going to be 7.533. Okay, and that's inches cubed. So we have our density, which is 0.26 is equal to our mass, which we don't know, over 7.533. So if I multiply 0.26 by 7.523, I end up with 1.958. Actually 1.95858. So I'm just going to round this to 1.96, and that's going to be kilograms. All right, so that's how you find or that's how you use the density formula to find different missing pieces.